I'm Joe Polachek. I'm with the PMI support group, and today I'll be going over Provision. And for the recorders, the one thing you want to make sure is the status LED is flashing. If the status LED is not flashing, the recorder is not recording. So make sure that LED is on. The Revolutions have a LAN for the Ethernet that flashes kind of a heartbeat. And if you have the cellular, the wireless LED will be on. There are batteries in these recorders. And so if you have a low battery, that status LED will not flash when you put the recorder on power. On the Eagle, that status LED is between the connectors on the top. And again, flashing green to make sure that it's recording. And also on the bottom of the Guardian is an LED, and also on the other socket recorders that should be flashing. Also, when you go to connect the recorder up, always put your Flexi T's or TLRs in first, and then go ahead in a clockwise manner and put in your other voltage leads. The recorders power up on the white and the black. We don't record anything on the white. So you have channel 1, 2, 3, and 4 on the Revolution and the Eagle 440s. The Flexi T's and the TLRs have an arrow. I kind of highlighted that arrow on this one. And that should point towards the load. Now, if you get that backwards, you'll see negative real power in your data files. But you can also flip that around using the scale factor, and I'll show you where that's at. Also, the Flexi T's have a 100, 1000, and 5000 amp ranges that you can set. There's a 1% accuracy at each of those ranges. But if you really need to record, say, half an amp, you can double wrap these and get you a lower, it'll pick up lower amperages. I'll show you in Provision where you can adjust that too. And if you're not working with the recording, whoever you give the recording to, you need to make sure that you tell them that you double wrap the Flexi T's. Let's go ahead and take a look at the Eagle and Revolution hookup diagram. And you can see, again, in Provision, you'll be initializing the recorder, and you would set it up for a Y circuit type, which is the default. That is phase to neutral voltages. If you have a 4-channel recorder, that yellow voltage lead is optional. And they are sealed inside, so you don't have to worry about water getting in them. The other option is a 3-wire delta, so if you want phase-to-phase voltages, or if you're working on a true delta configuration where there is no neutral, we still need to power the recorder up so the white and the red go on the same phase. And that 3-wire delta works for open delta and also 2-element delta. There is a 2.5 element Y that you can select, and also a 4-wire delta configuration. Now you'll need Provision. And we have a question on that's asked if there are different Flexi T's. There's only one, the latest Flexi T's are all rated at 5,000 amps, but all of them can be set to the 100, 1000, or 5000 amp range. There are older Flexi T's out there that are about half an inch in diameter. Some of them are green, some of them are kind of red. Those had fixed amperages. But the new ones that are about a 1/4 inch in diameter, you can those are rated and are adjustable. So to get Provision, you want to go to the support page. There's a ProVision Getting Started video that you can look at to refresh yourself, and a couple other videos there. If you go to the downloads, if you go under manuals, you'll see manuals for your recorder. And if you go under documents, you'll see the hookup diagram that I just showed you there. And under the software, there is ProVision that you can download, and ProVision is free. But you also need the USB driver, and that's for connecting any recorders to your PC. At any time, you can call the 800 number, 800-296-4120. You can also email support@powermonitors.com if you have any questions. And you see on our website there we do have a chat. There's a lot of information in ProVision. You can get quite a few of those questions that you have answered in the library. I would click on all. You see there's case studies there also. But if you go to the bottom and click on all posts, these are all our single topic white papers. And we have 300, if not more. You can also do a Control F and then type in a keyword. So if you're looking at harmonics, and then that keyword will be highlighted. So let's go ahead and take a look at ProVision. When ProVision comes up, you have an Explorer column where your data files will be downloaded to, and mostly they go underneath recent downloads. You have a Devices column where your recorder will be shown. And you have then a workspace, so if you double click on a recording, you'll get a check mark in there, and then the header report will pop up. If you need more room, you push the push button, it'll go off to the side, and you can hover it back, and the push pin will bring it back out. If you hit the X, it goes away. You can always find it under the View tab, so anything that's not checked is not on the screen. So you just click the unchecked selection, and it will pop back out again. If you need to do any file cleaning or emailing files to someone, there's really not a lot you can do inside of ProVision. So if you right click, you can see you can edit a report, the header file, which is basically just those couple of lines at the top. But there's really nothing else there that you can really do with that. But if you go up to the heading, in this case recent downloads, you can do an open and explore. And then all your data files will show there. So this is just like any other folder in Windows. You can delete these files if you want to do some cleaning up. You can compress them by going ascend to and compress if they're large. You can select multiple files and compress them into one file or one folder. And you can also copy and paste these, send them to via email. Usually 25,000 KB is the limit for email, so you may have to compress them and then send them that way. So I have the Revolution plugged in there. Let's go ahead and start with checking the battery. You can right-click on the recorder and get the same options that you get under the Recorder tab. And to check the battery, click on Identify. Then click on View. And the lithium battery voltage will be at the bottom. So this is real important that you do this before you send the recorder out. If the battery is getting down around 2.6 volts, ProVision will start to complain. You'll see a little pop-up there that says critical battery voltage, but to check, just go ahead and look there. If it is around 2.6 volts, you probably have a few months before you so if you really need it, you can still get a recording out of it, but it would be best to send it in and get the battery replaced at that time. It's critical that you do that so that you don't lose any data. There's also a firmware version for the recording, for the recorders. If you go to the Help tab, there's a check for updates. So if a new ProVision is out there and you're on the 1.90, you can click on the upgrade. And usually without any admin rights, it can go in and just upgrade a few files. You'll also find that there's firmware available. You want to upload that to your PC or laptop. And then when the recorder is connected, it compares the firmware that's on your recorder to the firmware that's in your ProVision. And if the recorder is behind in that firmware, the next time you download it, you'll be asked to update that firmware. Now the header report shows how the recording was set up. So you can see we have a start and stop time, when it was put on power and was taken off of power, how many days, some information about when it was recorded. Interval time. The Revolution samples at 16,666 samples per cycle. The Eagle sample at 256 samples per cycle. The interval time is what your graphs look like. So if you have a 1 minute interval, every 1 minute will be plotted in your graph with the lowest cycle during that 1 minute, the highest cycle during that 1 minute, and then it'll take all those hundreds of thousands of samples and give you an average for that 1 minute. Now you can adjust that when you set up your recorder. 1 minute is good in 95% of the recordings. It gives you enough information to help you figure out what's going on with your power. There are certain times where you might want to go lower to get more granularity in your graphs, but 1 minute is fine for most applications. The memory in the recorder is set up with the interval data, so this information down here under interval is most of the recorder's memory, and then there are additional reports and graphs that will show up on your header report that have their own limitations and memory size. And these will change depending on what they find. So if there is no significant change, they won't be listed. You may see power outages listed there. You may see loose neutral information listed there. And under interval data, if we only chose 3 channels, then channel 4 would have no's in it. You can see this one, frequency was not recorded. We do record frequency only on channel 1. And then if you recorded harmonics, you'll see which harmonics were recorded. And for the Revolution, if you recorded interharmonics, those will be down there also. So where does this information get set up at? Well, there's several different ways. If you download a recording and then say yes to initialize, it will set up that recorder with the same settings that that previous recording had. So if this is exactly how you want it set up, then that would be what your next recording would look like. You can also go in and retrieve settings. So we're pulling the settings out of the recorder. And you can go in and change those settings and then finish and initialize those settings in there. And then when you apply power, recording will use those settings. At first, the LED will flash on and off, and that's when it's setting it up. And then again, when it's recording, it'll flash every 5 seconds. Now you can also click on Initialize, and this is what I say is initializing from scratch. So we're basically using the default template, and it's getting set up. So you go through and set all those up. Now, the other thing you can do is you can create a template. So you don't even need the recorder. So if you have a recorder on site and you know you're going to go out there and change it, you can set up a template. And you do that by right-click on recorder settings and then create template settings. And then you choose which recorder you're going to use. And as you click on these, you'll see you'll get a picture of the recorder. So if you know that's not your recorder, then you have the wrong one selected. And we'll click on the Revolution. So on the basic screen is where you can set up your interval. You can select how many channels you have. And you select your current range. Your interval, again, you can adjust your interval, but that will also adjust your record time. So you can see the record time, this recorder does have a 1 gigabyte memory. You can go all the way down to 1 cycle, so you get an average, but you also notice that there's only 1 day of recording. So the interval impacts the amount of record time that you have. But in most instances, 1 minute is acceptable. Then you have the number of channels. If you're not recording 4 channels, you go 3 channels. It will also increase your record time. And then you have your current ranges. So if you're using TLARs, you have a 20 amp current range and a 200 amp current range. At 20 amps, if the TLARs don't see anything over 10 amps, it will cycle it down and you'll see a 10 amps on your header report. So whatever you selected here will also be reflected on your header report. Good middle of the range for FlexiTees is 1,000 amps, so it'll go up to, if it's approaching 1,800 amps, you probably want to go up to 5,000 amp range. If you're trying to match your revenue meter, you want to go to the 100, 200 amp range. And then also you have circuit type. Now the default is a Y circuit type. If you click on Enable Settings, you can change that to 3-wire delta or one of the other settings, or leave it on a Y. And then you have a few lines here that will show up at the top of your reports and at the bottom of your graphs. And you want to put in information in there about the site so that when you open that file up later, you know who it's from or what location it was at. You can go in and edit that afterwards, like I showed you. If you click on Advanced, you have a second option to adjust your interval. And you also will select which graphs you want to record. And as you select these, you'll see it's going to adjust your record time also. So this gives you another option to adjust your interval. Now we have voltage, current, power, apparent reactive, phase. Nowadays with switch power supplies, you probably want to go ahead and record voltage, total harmonic distortion, and current, total harmonic distortion. And that way you get an overall feel of what kind of harmonics are on the line. Frequency, you may or may not want to record frequency. In general, you really don't need frequency, but if you have any solar or any type of generation, you may want to record frequency just to make sure the inverters are also syncing up to the 60 hertz, because they can influence frequency. We do have a flicker report that is based on an IEEE flicker curve, the GE flicker curve. And what they did is they digitized that. So we have a PST graph, a short-term perceived flicker graph, that shows you the intensity and The stake in the ground for that is a 1. So basically, if your graph is below 1, then you don't have any voltage fluctuation. You don't have any flicker. If that goes above 1, then you are probably having some impact on voltage fluctuation. The IFL is instantaneous flicker, and that shows you more of the direction of your flicker. There are custom graphs that you can get. I can send you about 50 custom graphs all told, and they're from white papers. So you have to compare the IFL with current and with voltage, and if the IFL spikes match up to current inrush, then you know that the load is causing the flicker. If there's no voltage or current inrush and it's matching up to the voltage drops, then you know it's something further up the line, maybe a neighbor or something causing the voltage problem. When you record those, you also get PLT flicker, which is long-term perceived flicker, and the stake in ground on that is 0.85. So if it is below 0.85, it's less likely that you have voltage fluctuation. If you're recording harmonics, usually magnitude is sufficient, and you can put in 1-51 to record all the odds and evens. If you don't have a lot of memory in your recording and you need record time, the even harmonics tend to cancel each other out, so you can go ahead and put in specific harmonics, and really the first harmonic isn't really needed. Odd harmonics typically are the ones that cause the problems, and so you can type in the odd harmonics with the comma in between. Now on the Revolution, if you are doing IEEE 519 recordings, all you have to do is click on the daily, which gives you a 3-second interval. You'll need to record for at least a couple of days in order to get that daily report. The weekly, if you click on weekly, you get a 10-minute interval. And those set up this page automatically by clicking on those. If you have enough memory, at least 512 in the Revolution, you can choose the daily and also record for more than 7 days. You can get both the daily and the weekly IEEE reports out of that. So those two pages, the basic and the advanced here, set up all this interval recording. And then the next pages go through and set up these individuals. Waveform capture. Typically, I choose to uncheck the override box there. Sometimes when you're removing a recording, it bounces, and you could get overwritten. Good waveforms could get overwritten. So this is a snapshot of 9 cycles. You have 2 cycles, then you have the trigger cycle, and you have 6 more cycles. You can adjust these, so if you really want 60 cycles in a waveform capture, you can, but you do have fewer waveforms, and you are limited to waveforms. Your triggers are voltage threshold by percentage, and this is a cycle-to-cycle change. So in a template, if you can use it 120 or 277, setting it up by percentage works better. And then it's going to choose the lower of these. You can also record on absolute voltage. So if you kick these up higher, then you know that it's always going to be 3% of the voltage change. Or if you want a specific one, you can set up 15 volts, something like that, and then choose your percentage a bit higher. But it's going to choose the lower of those two when it's triggering. Your current trigger is based on a percentage, but it's also based on what you set your current range to be. So if it was 5,000 amps, then it'd be 40% of 5,000 amps. So you would have to have inrush of 2,000 amps from one cycle to the next in order to trigger a waveform capture. And if you don't have that, then you want to go ahead and adjust that. So 40% of 1,000 if you set it for the 1,000 amp current range. And then the revolution will trigger on voltage total harmonic distortion. 5% is pretty much the IEEE limit, the standard limit. Anything approaching 5%, you may want to start then, looking at individual harmonics. But if it goes over 5%, you definitely want to record individual harmonics and see which harmonics are causing that. But overall, you want a VTHD of less than 5%. You can also do period capture here. So if you don't think you're going to get anything to trigger on, you can say, I want to take a waveform capture every 4 hours, or 8 hours, or 12 hours. Normally that's disabled. If you are only using 3 channels, go ahead and set your 3 channels here and you'll get more waveform captures. And samples per cycle, if you want even more waveform captures, you can drop that to 128. You'll get fewer samples on each cycle, but you'll end up doubling your number of waveform captures. And then the Revolution does cross triggers. There's a transient option in the Revolution. So with that checked, that means that if it does take a transient, then it will take a waveform capture that includes the transient. A transient waveform capture looks about a third of a cycle, a picture of about a third of a cycle. And then event capture, I usually don't set that. That has to do with the next tab there. And I think it does double duty, and sometimes if you don't set the event capture right, you'll get a lot of waveform captures. Now, if you are setting a recorder and you're leaving it out there for a long time trying to catch an event, then go ahead and leave that overwrite checked. And that way when it hits 200, in this case 227, then it'll overwrite the first waveform capture. But it will hopefully capture the event you're waiting for. The next tab is event, and this is the event change. You want to make sure this is correct and kind of matches your voltage. So, if this is a template for 120, then go and set up your 3120. It doesn't work very well on neutral, so to keep from using the events up, you can just set 6 and 6 there. And the second column, you want to put in about 5%. So if you're putting in 277 here, then you probably want to go about 14 volts there. And 480, you want to go ahead and put about 24 volts there. But so what this is saying is that if your voltage goes outside or below 114 or over 126, you will get an event. And when you look at just the voltage graph, you'll see, like I said, the highest cycle and the lowest cycle during that interval. But it's not going to tell you on the lowest cycle, it's not going to tell you how many cycles it was down that low. So that's where the event capture comes in. So if you look at your event capture, it will tell you when it went outside of those trigger ranges, which channel was outside, how many cycles it stayed outside of that trigger range, voltage range, and what the current is, min and max during that event, before the event, after the event. So you can see if inrush caused the voltage to drop, or possibly a motor turning off caused the voltage to rise. So this is a good one to get correct. There's also a loose neutral setting that you can do here. This is a pretty tight loose neutral. So if you want to loosen this up a little bit, you can say 3 seconds. And then with loose neutral, one leg is going to be lower than the other leg. Usually it's a pretty good distance between them if it's a true loose neutral. And that would be the difference. So you could drop that down to 13 volts. And then the range kind of helps with false loose neutral. So if there's a single phase motor that kicks on, it drops one leg, kind of looks like a loose neutral, but not really. So that kind of keeps it from reporting false loose neutrals. The next tab is the flicker, and you can see the flicker report generated. This is based on the G flicker curve. Don't really change anything in that. The abnormal voltage would be the next one. And this comes down and figures out what's closest to the nominal. And then you have a plus or minus high range and a plus or minus low range. And then your abnormal voltage report that gets generated over here tells you whether or not it broke out of those ranges. Transient option, you want 2 to 3 times the nominal voltage in here. That's the only setting that gets set. You don't want to go too low because you just have a few of those, and it will fill those up pretty quickly. The miscellaneous page, if you have older recorders, they will show up here, older box recorders, and you can name your channels. There's some keyboard settings if you have some of those older recorders. But for the Revolutions, you have the option to adjust the memory. So if you do have a 1 gigabyte memory option in your Revolution, and you know you're going to be setting it out someplace for months at a time, you may not want to have an 800 megabyte data file when you get back. It takes a while to download those. So you can say, I just want to use 75% of that memory. Now it will cut back on your record dates, record times, but if you're leaving it out there and it's overwriting, it shouldn't make that much of a difference, and you'll have smaller data file. The significant change threshold, you can see it over here on your header report. This is a 1 second interval graph and report. And 3 volts may seem low, but it's a floating base on this. So it's a non-linear recording, non-linear report or graph. So if you have a 120 volt nominal and your voltage changes, say it goes to 125, the new setting will be 125. So it'll put an entry into the significant change event and set the new base at 125, and then the voltage would have to either go up to 128 or back down to 122, and then it will create another new entry. So it only adds an event when the voltage changes, so it's not based on time. But you can get a 1 second interval out of it, so it can show voltage changes faster than what your standard voltage interval graph will show. Now it is limited, and it's 1,000 events, which sounds like a lot, but if you set this on 480 and leave it at 3 volts, it'll fill up pretty quick. So 277, you may want to put this at 5 volts. If you're running recording 480, probably set this to 6 volts. Email, don't worry about, and the CBEMA is in the Revolution and the New Guardians. There's actually 2 curves here. The CBEMA curve is the orange curve, and the blue is an updated ITIC, International Technical Conference, set that up. These came from computer companies, and they wanted to see a 1-page graph with events that could affect their switch power supplies. So basically, any events which are going to be circles or triangles on this graph, if they're inside these curves, then they're acceptable and they won't affect a computer servers. But if those events are in the upper right, then it could damage power supplies, switch power supplies, that kind of thing. And if they're in the lower right, then it could slow down a production line, slow down a motor. But in general, these are, the gray is your plus or minus 5%, and then you can see it can go upwards of 500%. But these are very quick. So this is kind of broken into thirds. 1/3 of this is cycle duration, less than a cycle. So transients. 1/3 of this is about a cycle in duration, and then 1/3 of this is up to about 10 seconds. But they'll just be dots on there. And then there's a report on the CBEMA that will explain where these occurred and what voltage and things they came to. So we are creating a template. So we click Finish. You want to name it something that you can see later on, and then click OK. Then you'll see that template moved up to the top there. And then when you put your recorder on and you have your recorder listed, all you have to do is left click on that and drag that down on top of the recorder and say yes, and then we'll initialize it with those settings. Now, a template does max out, so it assumes that your recorders have the maximum memory. So what you may want to do after that is go ahead and do a retrieve settings, open that up, and then just verify that your record time is correct. And if you don't have enough record time, you can adjust it there and then cancel it. So you can have multiple templates. You can have them for different voltages with or without harmonics. If you have the Guardian recorders, you're pretty much going to be using same setup on those. So it'd be real easy just to create a Guardian template and drop that on your Guardian whenever you need to initialize it. Or like I said, once you download a recording, if you say yes to initialize, then you will get the same settings as the previous recording. A couple of things I mentioned earlier was Flex CTs and getting that arrow pointed towards the load. If you happen to open up your real power and you notice that you have negative real power, that is one clue that your Flex CT is on backwards. It could also mean that you have solar and or some other generation that's putting out more than what they're actually using. But if it is a Flex CT or TLR on backwards, all you have to do is go in and put a minus in front of that current channel, and then click OK, and it will save it to that data file. So even if you sent that data file to someone else, that setting would be in there. If you double wrapped your Flex CTs, you need to tell someone who is working with the recording, and if it's double wrapped twice, then you would put a 0.5 in there. If you got it around 3 times, you can put a 0.33, and 4 times a 0.24. And then if it's on backwards, you can put a minus 0.5, something like that. And then when you click OK, you have to go in and double click again on that, and then you'll see those settings adjusted in there. So that was tools and scale factor. Now, the other thing that you can do with scale factor is if you're recording on a secondary, you can put multipliers in there. And so if you have a 50 multiplier, you can put your 50 in there. I recently came in and someone had a current multiplier of 1,000 on their secondary. So you can put that in there, and then click OK again, and those multipliers would show up here, and then your voltage would be multiplied by whatever number you put in there, and your current would be multiplied by whatever number you put in there also. Okay, so let's take a look at abnormal voltage here. Just clicking on this, you'll just see that it tells you whether or not you broke out of the low range. And The reports do tell you what those settings are. So here we have a plus or minus 6 and a plus or minus 12. So on these dates, we just broke out of the low range. Now you do have to look and see if your start and stop times coincide with any of these events, because you can, again, bounce the voltages when you're installing the recorder. So you can just disregard any of those. I'm going to go back to my header report that's up here, and we'll take a look at significant change. So this was the 3 volt floatings, and you can see right here that you have a 1 second difference. So it went from 116.4 to 123.8. So if someone's complaining about flicker and they actually wrote down times, you could look through here and you see it goes channel 1, channel 2. There is a graph that goes along with that. So if you go into your graph tab, RMS interval, and then significant change reference, in your graphs you can always right click and you can see you can increase and decrease the zoom and zoom in and out there. So I'm going to hit my K key and darken that up a little bit so you can see it. But you can see your voltage fluctuation. So again, if someone's complaining about flicker, or if you see a loose neutral, someone's complaining about equipment burning up, you can see pretty much in one glance the whole recording. Now there is a limit there of 1,000 events. So up here this tracks your cursor. So if you put a cursor, say right there, it will give you the voltage of 116.4 and also the time that occurred. So if we go over here, let's go down to, you can see we have a 112 there. Now there is a toggle point table that you can use also, and I'll show that later on too, but right click and select toggle point table, or just hit your T key. Your T key will toggle that in and out. And then if you put your cursor there, you can see what those are. And in this case, like I said, it's not a linear, so it's going to change depending on where that event is. And you can zoom in on these and look at those closer. One of the other reports, especially if you're looking for flicker or looking for high voltage or even loose neutral, if you go into the report and single cycle histogram, there is an RMS voltage. Now the recorder collects all the raw cycles, voltage cycles and current cycles, and puts them into a bucket. So in voltage, it's the closest bucket. So in that first column, we have our voltages, and they do round up and down. So as we slide down here, we can see that we had one cycle at 112 for channels. This is channel 1, channel 2, 3, and 4. Don't know why we have that voltage on 4, but we do. But you can see, and it does go down all the way to 599. So you can see every cycle that was recorded and where that voltage came in at. So we had 26 cycles at 115. So if they're complaining about flicker, then you would see a lot of cycles down here. Of course, high voltage, we are hitting about 128, which really can be 127.6. And the one thing is, once you see this, you can go to your report again, and there's a voltage out of limits. And sometimes you get a lot of zeros, voltages. So if you don't want to get too many, and you do have a lot of numbers down in the zeros, just put a 0 there. And then we're going to put 127 here and mins and maxes. And we can see when some of those voltages occurred. So channel 2 had 127, 127.6. So these all occurred on 515 and then another one on 529. And neither of those are our start or stop time. Now, any reports you can right-click on, you can send that to Word, Excel, HTML, or comma separated value, which is an Excel type report. And then since we have quite a few things open here, we can go to this little down arrow there and click on that, and it'll show everything that we have open. So then if we wanted to close one, we can go and just X out then once we go there. So it's an easy way of moving around if you have multiple graphs or reports open. Flickr, we didn't see a whole lot of Flickr in either one of those previous reports or even in the graph, and so we wouldn't expect to see a whole lot here. If you recorded neutral, you may see a lot of chatter on the channel 4 if you have that on neutral for the Flickr report, and that's kind of normal. You really don't worry too much about Flickr on neutral. Since it's a percentage, neutral is usually very low voltage, so 0.4 just changing by 0.9% could happen quite a bit. So if you do see small amounts there, then your voltage is pretty stable. But any events, and you'll see there is a limit, and then if that limit is exceeded, then it will create an entry in this report. And it just tells you at what time we had a 0.9% tolerance over a 10-second period, and we had 6 times it broke out of that. The event change. Now in this one, we did go over 126 quite a bit, so we probably, if we're going to re-record it this time, may wanted to adjust our plus or minus, maybe make it plus or minus 7, or maybe raise our 120 up to 122, something like that. But you can see that at this time, channel 1 for 96 cycles was outside of basically higher than 126. So, and this is channel 1, channel 2, channel 3, and channel 4. The min and max for the current is during those number of cycles, so during that event. Previous is what the current was before, and post is what it was after. So you can kind of see if there is inrush, is that would cause the voltage to drop, or maybe a motor turned off. Waveform captures. You can click on a waveform capture, and again, you should see whatever your setting was. So normally 9 cycles. This is the trigger cycle. So when you see a date and time, this is the 3rd cycle. So this would occur in this area. You can page down and page up through these. And down on the bottom, you can see that this was flipped around. So this, if you have your Flexi T on backwards, and if this was neutral, this would be normal for neutral, but you wouldn't see that much voltage on there. But your waveform captures can also tell you if your Flexi Ts are flipped around also. I'll come back to waveform captures in a bit. Transient captures. Again, the revolution will do transient. So you can see it's in microseconds at the bottom. So basically pretty close to 1/3 of a cycle is what you'll see there. And the IC BMO don't have a whole lot going on there. But if you go under the report tab and choose the report for that, you can see when those occurred. Type 1 are the transients. Type 2 would be type 2 are the cycle and duration. And then there's the 3rd type, which actually shows up as none for the greater than 1 cycle. And then you can choose your voltage and look at your voltage. But we're going to go ahead and we're going to go up to the graph tab, RMS interval, and then RMS voltage and current. And you can see it looks kind of busy, so we have all these circles and lines. And I'm going to left click my mouse and drag it across and zoom in there. And so if we click on a circle, you see the cursor turns to a finger. Click on a circle, it'll take you to the event change that occurred at that location. So this way you don't have to go through and look at the graph and try to compare, when those occurred. And if you click on one of the lines, that will take you to the waveform capture that occurred at that point. Now with the revolution, you can go into the report tab and there is a list of waveforms and it will tell you these were event captures. Like I said, that's kind of why I normally don't choose event captures. And remember, our event captures were configured for 126 and the voltage was pretty much over 126 that whole time. So. And you can just click on the number there to open up that capture. But see, a couple of these were from voltage percentages. And one was from THT. So the third one there is from THT. And we see a little bit of not too clean a sine wave there. Now you can right click. You can unzoom one level or unzoom all levels. You can hit your U key is a shortcut to unzoom one level. A Z key will take you all the way back out. We can right click in here. We can take those annotations off. And let's go ahead and zoom in on this section. Zoom in one more time. I hit my K key and darken it up a little bit. So we have voltage on one side, we have current on the other side, and again, this follows everything that's on the left side, so this is going to follow our voltage. We can hit our toggle point table. Let's zoom in a little bit more for that. So we're going to hit my toggle point table, and then when the cursor turns to a finger, just left click, and you'll get the voltage and current that's on there. And as you hit your left and right arrow, you'll see that it moves by the 1 minute interval. So we're at 122, 123, and then it dropped down to about 120, so it dropped a few volts there. And got about 348 amps there. Now one other thing you can do, still looks pretty busy. One other thing you can do is your less than and greater than key, so your comma and your period. If I hit my greater than key or the period, you'll see it'll drop down that current. Kind of make it a little easier to view. And the comma will bring it, or the less than will bring it back up. Now, I get a lot of people sending me data files, and a lot have to do with Flickr. So what you can do also, again, it's still pretty busy. Lighten it up a little bit. Under the Tools tab is a Select Plots. So you can go in and you can say, well, don't really care about channel 4, so let's just look at channel 1 and 2. Make it a little easier to look at. We can go in and we can say, well, I just want to look at current max and voltage min. Current max. Now I'm holding down my control key when I'm selecting these. And I'll click OK. And so what we have is we have the minimum voltage in the green and the maximum current in kind of the pinkish. If we hit our Z key now, we can see that it goes all the way out. And we'll even drop that a little bit. But so anything that doesn't match up with the inrush would mean that any of the voltage fluctuations are coming from further up lines. So here you can see we've got a couple of couple of small drops here. So that's a pretty easy way to see if the load is causing. Again, you can use your toggle point table, and so we only dropped a couple of volts, but gives you the idea there. And you can use a slide bar to go across and just kind of see, is there any areas. So we do have something further up the line that's causing some voltage to drop, but not significantly. Now, if you're in a graph, there are annotations in the graph. And there's also properties on the side. So again, if you don't see these properties, go back to your View tab and just make sure it's checked. At the bottom of the screen, the graph is those couple of lines that were in your initialization screen. So if you needed to change that, if you're trying to create a document and you want to adjust that, you can go to Properties, and you can adjust those lines or add to those lines there, and that's just going to be for this graph. It's not going to affect the data file. If you don't like our colors, you can also go in and you can change those colors in here also. And again, it's just for this graph. Up at the top, you can put in annotations. So once you click on an annotation and then click in your graph, go to the properties, and then you have the annotation for that graph. You can change the color of it, and then you can also change what wording you want to use there. There's one of these kind of pointers in there also. So again, once you put something in there, go to Properties, and then you can change those. A nice one is the line. So if you click on the line and then put a line in there, and you go to your properties, you can fine tune where that line actually goes to. So if we wanted that at exactly 24 volts, we can just leave that there, and you can see that's 124. And then put text there, and so that'll put that line at 124 volts. Now from there, you can right click, you can export that dialog, and it goes to a clipboard. So if you click export, you can paste that into a Word document, or a PowerPoint slide, something like that. If you click on File, then in this case it'll save a JPEG file, but you can also choose one of the other file formats. But by default, it goes to the clipboard. Now, if you go ahead and close this, if you X out on that, it'll ask you if you want to save it. You can say yes. And then underneath the data file, you'll have this saved graph. So you can come back and you can review it. You can still use and fine tune it if you want. And if you need to change anything, again, just click on that and go back to your properties. So that's a way of adjusting graphs and saving graphs. So voltage THD, again, 5% is what you're looking for. Less than 5%, I should say. So you can see here we're not even getting up to 2.5%. So our overall total harmonic distortion for voltage is good. Current THD, ITHD, you really need to go further in. You need to find out how much current are we actually running. So we're hitting upwards of 300, 330, 340. So this is a percentage of that. Usually what you'll find is the lower the current, the higher the THD is. So it's really not that big a deal if you have, 4 or 5 amps and 400% ITHD. The problem comes in when you have several hundred amps and a few hundred ITHD percentage. Then you're starting to run into problems. So you have to look at your ITHD, and you have to look at your current, and you have to really look at when it occurred. Did it occur when there really wasn't much current there, or did the high ITHD occur all the time? So you do need to do more. Nothing really cut and dry there. But if it is too high, the whole problem with harmonics is heat. And that heat will go back. It will damage a transformer, overheat the transformer, and cause premature failure on the transformer, among other things. The PST was, so anytime you see the green like that, you'll know it's averages. So 1 is the stake in the ground. So basically, except for a few little spikes here, overall there really wasn't much in the way of flicker. And the IFL, you have to go through and compare IFL to voltage and current. Now I do have custom graphs out there that I can send you. The custom graphs, when you load them, you can find them underneath custom graphs. They'll also be under reports, so you get a report for those. And but because I have so many, they show up underneath your graphs and reports down there. So you can see I've got quite a few on harmonics there. And if we come down here, we'll see that there's a VMIN, IMAX, IFL, and PST all in one. It's a little busy. So you have volts, amps, IFL, PST. And basically what you're doing is you're looking at your spikes on the IFL, and you can see that they correspond more with the drop down of current. So we don't have any inrush there, but we do have a voltage drop. So therefore it's not the load that caused this spike in the IFL. So something happened on that line further up. So if you really did have a lot of IFL in there, that's how you can figure out whether or not it's the load that's causing it. Again, you can email support@powermonitors.com and just say, Joe, send me the custom graphs. Tell you how to load them and everything else. Now, we did also record harmonics. If we click on harmonic in the header report, we get what I call the waterfall graph. We take the fundamental off. Did it pretty quick. So you right-click, and there's a show fundamental. You take that off, and you get an idea of where your harmonics are. And you can see, and it's pretty much typical too. Usually the harmonics fall fairly early. In the low numbers, and as you get towards the higher numbers, they fall off. You will see some in the 27s sometimes if there's some issues going on with motors and things like that. But if we go to our custom graphs, and we're just going to take a look. You can see the custom graphs are 1 through 6, or here's just the odd custom graphs we'll take a look at. And these are similar to the voltage and current graphs. So first harmonic, first channel, third, fifth, and you see they kind of start dropping off there. But I made some custom graphs for one of the customers. I broke them out here. They're by channel. So if we click on those, and I'm going to zoom around that drop. So what we have here is we have the voltage harmonics, and they're color coded. So you can see we have some fifth and some seventh there, a little bit of ninth. We have our voltage and our first harmonic, our current and our current first harmonic. And that's really why you really don't need to record the first harmonic. They should be exactly the same as the voltage and the current. And then you have your current harmonics here. The toggle point table does work on these also. And it can be, it'll show you all the harmonics that are there. Again, you can go under the select plots and you can go through and just choose a few of these. You know, if you just want to, again, just look at a few odd so it's an easy way to break them down pretty quickly. A couple other things. Maybe you are recording and you have left the recorder on site, but you've gone out a couple of times. You can combine those data files. And yes, to your question, custom graphs. Yeah, if you want the custom graphs, I have one file I can send to you. Just go ahead and email support@powermonitors.com and say, I'd like the custom graphs that Joe showed in the ProVision training. So if you have multiple recordings from the same recorder at the same site, all you have to do is you can combine those. So you can put the check marks into 3 of those, go up to File, and there's a File Merge. And it will, I still have the other one in there too. But if I clicked on Merge, it will ask for another file name. And so it will create a separate file, and it will combine all those data files into one. So your graphs will be continuous and you don't have to look at multiple files. You can end up with pretty large files. Now, not everything in the reports will be combined in there, but your graphs will definitely be combined. You can also, if you want to compare, maybe you have two recorders on the site, maybe one on the meter and one on a transformer. You can click on both of those, just put a check mark in front of both of those, and then go up to your graph tab and then choose the graph that you want. And you can see I have two files now. You can right click on that tab and you can do horizontal or vertical. So then you could go in and you can zoom in and you can compare one to the other. You can move that back. If it's a report, you can do vertical, and they'll line them up side by side. There are also a couple of other tools. One of them is a custom graph wizard. So if you want to create your own combinations, create your own graphs, you can choose up to 6 plots, and all you have to do is click, and it kind of shows you what's going to be going on over there. So we have 3 plots, and just click Next. Here you label it, so whatever you want to change on this side right there. And then you have a selection of what you want to graph. Maybe you want VTHD on one side, and you can put channel 2 over there if you want, and maybe you want to do VTHD on both sides. And then for each plot, you would go through and select what you want in there. Where it comes kind of confusing possibly is what you want. So if we had VTHD on the left, we'd want to make sure that channel 1 was there, but we wanted channel 2 on the other side. And then, of course, you'd have to go through and set up your other plots too. And it kind of shows you what's going on there. You can see channel 2, but you can always go back and fix that. And then the colors. So go through and choose which colors you want in there. The next one is the legends. So what's up at the top. So what I usually do is go back and I'll look at one, figure out which color I want out of that, and then go next. And then create a legend. Channel 1, VTHD. And color it. And then go back and figure out what I want in a second. So I'll go back and forth between these two and color those. And then you, so what title do you want at the top of your graph and what do you want to call the template? Usually these are the same. And then when you click next, it'll go ahead and create the template. And they will show up down here in the bottom. And from there, you can go back through and test them. You know, if you didn't get them right, you can edit that with the Graph Wizard. And if you need help, you can always call in. We'll help you with that too. There is also a trace mixer template. First, let's go ahead and open a graph. So I still have 2 checkboxes there. So if you wanted to combine these into one graph, you can do the trace mixer template or trace mixer graph. This one's kind of confusing, but what you do is you select what you want out of the one file and then select what you want out of the other file. And remove those, and then so you can also create a template there. You notice one's at one side of the graph and one's at the other side. But you can also create a template so that any 2 files that you select, you click on, it will do that also. So ProVision has a lot of tools built into it. One final tool is the Graph and Report Publisher. You can select a number of reports and graphs. So these are under graphs. So select your graphs, and then go underneath your reports and select your. So you can put them all together. If you're going to do any custom graphs, or if you're adjusting and putting any labels or things, annotations on your graph, you can go ahead and just create the reports and then copy those graphs into the report. But this one will take the default graph and these, and it will create a report with that information in there. And you could go in and you could put in your company's logos and things in these also. The other thing is, so there are a lot of reports underneath there. If you go to those reports, though, you're going to get a report for the whole recording. If you recorded for several months and you just want a report for, say, 2 weeks, what you should do is just go ahead and open up the graph that you want the report for, and then zoom into that 2-week time period, and then right-click, and there's a launch report there. And then you'll get a report out of that. We're coming up towards the end here. I do want to show you some of the waveform captures. So if we go into waveform capture, there's actually a lot of information in the waveform captures. So by default, you get the standard waveform capture, but under the graph tab, You know, in the peak to peak, you can't really tell from one cycle to the next how much the voltage really changed. But if you go down to the waveform capture, there's actually an RMS capture. So if we click on the waveform 8, then we have nothing too exciting, but we have the RMS voltage there. And then, so you can compare those and see how much voltage it changed. You can also get harmonics out of this. So if you look up here, we have a VI waveform, which is what we have open. We've got an RP for real power. We have a harmonics, we have a vector, and we have a parametric waveform. So basically, if we click on the vector, it will show us the vector for that waveform capture. Now we are only looking at one cycle. You can move that over. But here too, if your Flex CT's on backwards, you'll see these about 180 out from where they are. So if they're close together like they are, then you know your Flex CTs are on good. You can also change to a harmonic in here and see what your harmonic is. Now again, we're just looking at one cycle. If we go and we click on the H for the harmonic, we get harmonics, and we can see that we have total harmonic distortion there. So again, we're looking at just a small sampling, but harmonics should be repeatable. So the THD will give you an idea of what your total harmonic distortion is. Even if you didn't record THD or didn't record harmonics, you can right click and you can do show fundamental. And you can page down and page up through these two. So there's a lot of information in ProVision. And you can see your harmonics. One other thing I'll show you, since we're coming up to an end, and even in waveform captures, you can right click, you can launch the report in there too. If you have a recorder connected up and it's on power, now you can connect the USB to a recorder. But the USB is not rated at the 600, 1000 volts that all our other leads are. So it's mainly a matter of safety. If you feel safe doing this, you know, and 120 compared to 480 would be completely different. But you want to be safe. But you can hook the USB cable to a recorder that is recording. But you want to make sure there's no cuts in the cable or anything like that. Now, if you're in a Cell Revolution, you can go in and you would connect to the Cell Revolution. You'd also have to connect any old recorders, so you'd have to set that up first. I didn't cover that, so if you need any help connecting up to remote recorders, give us a call. But once that recorder is in ProVision and it's on power, you can right-click, and then you have live data here under waveform capture and meter display. So waveform captures, close that out. So it'll show your live waveforms. And for meter displays, if you go to main readings, it will show your voltage, current, power, tell you whether or not your current range is set up. You see I'm actually in the countdown since I just plugged mine in. But you should wait till it's actually flashing on and off every 5 seconds. But this is a good way to know if your recorder is connected and reading properly. A lot of the recorders have Bluetooth, so you can connect up in Bluetooth if you don't want to use a USB cable. And you can do look at live voltages while you're in Bluetooth. You can also initializer recorder. Now, Bluetooth is real slow, so you don't want to download any huge files. But you can also do this over cellular. And we do have some Wi-Fi devices also that you can connect to. So ProVision is a very powerful tool. There's a lot of information there. So again, call in 800-296-4120. It is 7 days a week, 24 hours a day. We'll help you out as best we can. And if you have any last questions, go ahead and type them in at this time. And if you have any questions later on, you can always email support@powermonitors.com. So I'm Joe Polachek, and I'm with the support group. And we can get you a recording of this, I do believe. So why don't you email marketing@powermonitors.com, and they will set that up for you. Thanks for attending today, and hopefully we'll see you again. Have a great day. Have a great weekend. So long.